Life cycle assessment is a cradle-to-grave or cradle-to-cradle analysis technique to assess environmental impact associated with all the stages of product's life, which is from raw material extraction through materials processing, manufacture, distribution, and use.
Let's look at the benefits of life cycle assessment. Life cycle assessment allows the decision maker to compare two products and select the one that has the lowest impact on the environment. Rather than optimizing one indicator, LCA provides a holistic view of environmental impacts to avoid optimizing one environmental indicator. Furthermore, LCA allows for the identification of environmental impact hotspots. Life cycle assessment also has limitations that sometimes lead to skepticism about LCA results. In addition, performing an LCA study is resource-consuming mainly due to the large amount of data needed. If data collection is poor or if not enough data are available, the study will not lead to solid conclusion. To overcome the limitation, improve harmonization of LCA study by more stringent generally accepted guidelines will reduce the variation in LCA studies.
And hi everyone! So today let's learn something about life cycle of the environmental impact of the t-shirt. The sustainability index of the cotton t-shirt using the life cycle assessment or LCA is to monitor the cycles of a product. Analysis of LCA of a cotton t-shirt is significant indicators water, energy, land and work. The negative impact also shown in LCA.
Good day everyone, my name is Priyadashni Anpalaga and today I'm going to talk about LCA case study where open looper recycling, a LCA case study of PET bottle to fiber recycling by Lee Shen, where this study assesses the environmental impact of polyethylene thermometer with PET bottle. As for the result, was showed where compared with the virgin PET fiber and other commodity fiber like cotton, rice and PP and PLA and polyic acid, where the LCA results show the recycled PET fiber offer important environmental benefit over virgin PET fiber, depending on the allocation method applied for the open loop recycling. And the recycled fiber are produced from chemical recycling allowed to reduce the impact in 6 out of 7 of a total 9 categories compared to a virgin PET fiber. For the conclusion, PET and B2F recycling offer important environmental benefit over single-use virgin PET fiber, where PET fiber is a product that cannot be further recycled via mechanical recycling. So chemical recycling is technically possible, but the economic viability of a large operation is still very proven.
Based on this study case, LCA has a drawn mass attention from both industry and academic. However, the level of Korean related to the LCA studies with respect to the different sectors. Therefore, the objective of the study is to assess the status of environmental life cycle assessment LCA studies in South Korea. So the majority of this study focus on the construction and energy sector, with the fewer and environmental studies on the manufacturing, transportation, agriculture, and information and communication industry. So with the active participation in the international conference and collaboration with the other countries, Korea has progressively developed its holistic methodological approach and database for LCA.
Today we will start the webinar with the first presentation entitled Life Cycle Assessment LCA. What is Life Cycle Assessment LCA? LCA studies the environmental aspect and potential impacts throughout a product's life. Example, cradle to grave, from raw material acquisition through products use and disposal. Next is about the limitations of LCA, the exclusion of economic and social factors, distinguishes LCA from product line analysis, PLA, and similar methods. This separation was made to avoid overload, being well aware that a decision, for example, in the development of sustainable products, cannot and must not neglect these factors. Next is life cycle of product in LCA. All stages of product's life are taken into account, such as resources use, material processing, product manufacturing, distribution, use of products and end-of-life operations. LCA may even evaluate specific phases in the production process and identifies the life cycle stage where environmental consequences are the greatest. Companies can then select how to. What is functional unit? Functional unit is most frequently defined as the provision of 1000 liquid in a way to fulfill the technical aspects of the performance. This function can, for instance, be mapped with different packaging specifications. The following examples are arbitrarily chosen. Example: the life cycle of 5,000 pouches, 2,000 reusable glass bottles, 1,000 cardboards and 5,002 PET bottles are 4 product systems that roughly fulfill the same function needs to be analyzed and compared. LCA is system analysis. LCA is based on a simplified system analysis. The simplification consists of an extensive linearization. System analysis and the meaningful selection and definition of system boundaries are therefore important and labor-intensive tasks within every LCA and operational input-output analysis. Gate to gate, there is always a risk of problem shift when system boundaries that are too restrictive have been chosen. This is often the case when only operational input-output analyses have been conducted. Frequently misused terms are eco-balance of the enterprise, corporate LCAOE eco-balance without additional explanation. Let's recap from previous slide. True or false question. LCA is based on a simplified system analysis which includes an extensive linearization. True, false. The answer is true.
Standardization of LCA. LCA standardization by national standardization organizations by ISO has been conducted since the beginning of the 1990s with great effort. ISO 14040 LCA, Principles and Framework International Standard 1997, ISO 14041, LCA Goal and Scope Definition and Inventory Analysis International Standard 1998, ISO 14042, LCA Life Cycle Impact Assessment, International Standard 2000, ISO.
LCA standards ISO 14040 and 14044 belong to the ISO 14000 family concerning various aspects of environmental management. The most important standardization activity for LCA is therefore conducted by ISO.